And we go straight to the last one, and that's number 40. Given that sine x equals 4/5 and cos y equals 12/13, where x is an obtuse angle and y is an acute angle, find the value of sine x minus y. Sine x minus y is the same as sine x minus y is equal to sine x cos y minus cos x sine y. So now we need to find sine y and cos x. So how do we do that? They already told us that x is an obtuse angle while y is an acute angle. So let me do this. Let me call this. Let's check this first. If this is angle 120 degrees, if this angle, for example, is 120 degrees, that's an obtuse angle. If I complete this right angle triangle here, that means this is going to be 60 degrees. This will be 60 degrees. If I want to find sine 120 degrees, I can use this acute angle 60 degrees to find it. Sine 120 degrees is the same as saying sine 180 degrees minus 60 degrees. And I know that in the second quadrant, sine is positive. So that means sine 120 degrees is the same as sine 60 degrees. If I want to find cos 120 degrees, I want to write it. Cos 120 degrees is the same as cos 180 degrees minus 60 degrees. And that's going to be, because I know that cosine is negative in the second quadrant, that means it's going to be the same as minus cos 60 degrees. So that's how you find the trig ratio of an obtuse angle of any angle in the second quadrant, which is an obtuse angle, in terms of an acute angle. If I want to find tan 120 degrees will be the same as tan 180 degrees minus 60 degrees. And I know that tangent is negative in the second quadrant, so that's going to be the same as minus tan 60 degrees. So here the obtuse angle is x. The obtuse angle is x. Let me call it x. That's the obtuse angle. The obtuse angle is x. So let me call the acute angle that corresponds to it x1. So if they said sine x is 4/5, so if they say sine x is 4/5, that means sine x, which is the same as sine 180 degrees minus x1. Don't forget that x1 is the acute angle that corresponds to x. So that means sine x, which is the same as sine 180 minus x1, is going to be sine x1, because sine is positive in the second quadrant. And if sine x is the same as sine x1, that means sine x1 is also equal to 4/5. So in this right angle triangle, sine x1 is 4/5. That means opposite is 4 and hypotenuse is 5. And if we use Pythagoras' theorem, we'll be able to find this place, and this place will be 3. So now what is cos x1? What is cos x? I know that cos x is cos 180 degrees minus x1. Because cosine is negative in the second quadrant, cos x is going to be the same as minus cos x1. And that's the same as minus, the cosine of x1 is adjacent of hypotenuse, 3/5. That's minus 3/5. So that's cos x. Now for y, that's simple, that's straightforward. Let me just draw a right angle triangle. And I know that in this right angle triangle, if this is y, cos y is 12/13. That means adjacent is 12 and hypotenuse is 13. If I use Pythagoras' theorem, I'll be able to get this as 5. I'll be able to find this and do it 5. So that means sine y is opposite of hypotenuse, which is 5/13. And now I can find with sine x minus y, which is, let me write it again, sine x cos y minus cos x sine y, and that's equal to sine x is 4 over 5 times cos y is 2 over 13. That was already given in the question. Cos y is 2 over 13, that's it. Cos y is 2 over 13, you can see it in the question here. That times 12 over 13 minus cos x, which is minus 3 over 5. That's minus 3 over 5 times sine y, which is 5 over 13. That's times 5 over 13. And that simply means 48 over 65 plus minus and minus is plus, that's plus 3 times 5 over plus 3 over 5 times 5 over 13, which is 15 over 65, and that's simply 63 over 65. And that's it, very simply. Thank you very much, and I'll see you in the next. Bye bye.